And again, Atlantis' crew members down on the middeck with several of the crew members getting ready for tonight's spacewalk. Jim Voss and Jeff Williams configuring all of the tools and equipment associated with their spacesuits in preparation for that spacewalk. Commander Jim Halsell taking a break following his flawless rendezvous and docking with the International Space Station. And Mission Specialist Susan Helms in the foreground. And we'll be breaking away from the coverage of Atlantis, live coverage from orbit, to provide you with a detailed briefing on the activities by the two flight directors that oversaw Atlantis' docking to the International Space Station, and that press conference upcoming in just a couple of minutes.
Good morning and welcome to today's status briefing on STS 101. With us is lead flight director for STS 101, Phil Engeloff, and to Phil's right, the International Space Station flight director, Paul Hill. And we'll hear from each and then take questions. Phil?
Okay, well, it's hard to make it look any easier than the crew made it look today. This was really a textbook rendezvous. Everything went virtually exactly per the timeline, per the procedures. I came on console this afternoon just before the NC4 burn, which really sort of initiated the rendezvous for the day. That was a small burn. After that, the first tracking that we took, we got a little bit of an update from the ground tracking of about 6,000 feet downrange tracking error with the first Star Tracker pass, and that was pretty much all the significant tracking update that we took. Everything after that with the radar showed us to be right on target, and the procedure execution by the crew was virtually flawless. We flew the procedures, flew the approach just exactly by the book. When we did get to the station keeping point, when we got up to 30 feet, the angular alignment between the two vehicles was dead on, less than a degree in each axis, so no angular flyout was required. So we pressed on in from 30 feet, took the approach on in, and docked with the station. The contact velocities were right on, 1/10 of a foot per second, exactly as targeted. There were negligible lateral velocities or alignment errors, and it just looked exactly like it was supposed to. Everything was perfect. There just isn't a lot more to say. It's a good relief to get that milestone behind us. We'll be setting up for the EVA tomorrow and then ingress on the days after that, and we're off to a great start. Everything looks good so far. Paul?
Station team couldn't be any happier with the rendezvous. The FGB certainly performed like a champ. The node and the FGB warm-up are continuing for a Flight Day 5 ingress, and we're right on targets. And at this point, we're really just ready to get on with the EVA and 4 days worth of maintenance and repairs.
Okay, with that, we'll take questions starting here at JSC if we have any. Paul?
Paul Hoferston, space.com. Phil, could you sort of fill us in on what happened in the mission control room? What was the reaction there to this flawless docking? And I got a follow-up.
Okay, well, you said it wasn't a lot of reaction. This was almost a classic case of following the procedures. It was almost like a dry run in a sim with no failures. We started off as I say, entering the procedures about a half hour later than usual because we didn't require an NH burn, height adjust burn, that we often do because of this particular profile and the phase angle that we had. We were able to let the crew start a little later, which gave them a little more time after wake up this morning. We jumped into the procedures and started working our way through the checklist blocks, and it was very quiet, very methodical. Everybody was doing their jobs. The ground control team did a really good job of staying ahead of the crew and anticipating all of the information that we needed to pass on up to the crew. This crew and the ground team, I think, worked together exceptionally well as a team, and it was just textbook. It just went perfectly. And there's always a big sense of relief at contact and capture when everything works like it's supposed to, and a little bit of a big sigh of relief, I guess, but it was just very quiet and methodical today.
And then looking ahead to tomorrow with the EVA, the crew's taking a little bit of time off now, get rested up. Could you sort of characterize again what you think is the difficulty of that, and how much they're going to need this rest?
Well, there's a little bit of a misperception there. There isn't really much time off this afternoon. We have intentionally reserved about an hour block for the crew to sit down and review the EVA procedures. But after we've gotten docked today, there are some pressure equalizations with the PMA on the station to get ready for ingress, things that we could move up to today so that the ingress day isn't so crowded. We do take the orbiter cabin down to 10.2 psi today in order to help the crew become denitrogenated in their bloodstream so that we avoid decompression sickness when the crew goes down to 4 psi in the suits when we depress the airlock. And so there is some time required this afternoon to complete those procedures and get ready. It's not exactly a leisurely afternoon, maybe by comparison to the busy schedule of the rendezvous, but there's still plenty of stuff to go on. And aside from the reserved time today to do the procedure review, there's not a lot of slack.
Mark Carreau from the Houston Chronicle, and I'm not sure if it's Phil or Paul, but my question has to do with the EVA and the part about reseating the American crane. Could you give a little thumbnail of what you want the two spacewalkers to do when they begin that task?
I'll try that first, I guess. It is our belief that the hardware itself is fine and that all they're going to have to do is release it, take it out of the socket, reposition it, put it back in, and fasten it back down, and then they'll do a pull test to check to see that it is latched down securely. And everybody expects the highest probability is that's going to work just fine, and that's what we'll do. If for some reason that does not secure as we expect it to, we have an alternate location, a similar mounting point in a different location that we will try it. And while again we don't expect that to be required, that is the primary backup plan, so to speak. If all else fails and we can't get it secured anywhere on the outside of the vehicle, we can bring it back inside and eventually stow it in the node. There is one piece of the mechanism that seems to be the only possible place where we could be having a problem, and that portion of the mechanism could be unbolted and replaced. So what we would do is store this thing on orbit until the next flight, where we would bring a replacement part to attach at the base, and then we could take it back outside some later time and stow it in position. But the highest probability is it will just be secured back in its current location and latched down.
I had a second question for Paul Hill. In the briefings you gave before the mission to the news media, you talked about the protocol for changing the temperature and the environment inside the station, and your hope that the temperatures would be right so there wouldn't be a lot of moisture inside. I just wonder if you could sort of update, based on what you know at this point, or we just really have to look when the whole crew goes inside.
We do have considerable analysis that we've done for various options, if we have additional power failures, things like that. And we have a really good understanding of what it would take for us to get to the target temperatures. And overall, we're still on the profile of predictions that we had made pre-flight. So we are still warming up. We're trying to get the shell temperature up to between 22 and 25 degrees centigrade. That way it'll be above the dew point of the air, so that we won't get condensation on the shell walls as the crew goes inside the station and they're exhaling, and there's moisture in their breath as they exhale into the atmosphere in the station. Right now we have plenty of power. We have margin on top of what we're using to warm up the shell. So if for some reason we saw the temperature lagging and not meeting the predictions, we could turn up the heat some to make sure that we were warm on time. But I'm not concerned with this at all. We're definitely going to be warm on time.
Okay, I believe we do have some news media at the Kennedy Space Center that may have questions, so we'll go there now if they do.
Great. Good morning. Peter King from CBS News Radio. And this question is for either or both of you. I think, Phil, you probably said it best in the beginning when you said these guys make it look easy when it comes to rendezvous and docking. We've been watching these procedures going on for more than 30 years now. I want you to do me a favor in your best layman's terms, because, you know, those of us who cover this know how difficult this really is to pull off time and time again. But in your best layman's terms, for Joe Taxpayer, describe the difficulty of this maneuver and what really is accomplished every time.
Well, I think the most sensitive part of the rendezvous, or the difficulty, would be how you would respond to cases where you had a discrepancy between the tracking and what you actually saw when we started the rendezvous in terms of the relative position of the vehicles. The trick with the rendezvous really, and not to take anything away from the crew for the execution, but the trick in doing the rendezvous as well, I think, is in doing the pre-flight planning and making the procedures as resilient as possible to all of the different circumstances that you might see. When we did the rendezvous today, after what we call the TI burn, which is the last burn that targets you on an intercept course with the station, you do that with a certain amount of tracking, and then we do a number of mid-course corrections. And each time we did those burns today, we put in little bits of correction that improved the trajectory to intersect with the station as we wanted it to. In the cases where those burns don't put you on exactly the right trajectory, or the tracking isn't as good as you would have liked, and your onboard solutions are significantly different from the ground solutions, it takes a lot of work between the crew and the ground to decipher which are the better solutions, which are the best options to take. Today we were fortunate in that everything really went, as I say, by the book, and we could look at the solutions. They were within the proper ranges, and the path that we were supposed to take was clear. And when we do it like this, it really does look easy because the procedures are written so well and the crew executes them so well that it really is just like watching a ballet. But the hardest part really is in the preparation, and when you get to execute it without a lot of extra work, it looks easy, but trust me, getting there is not the easy, is much harder, and that's what makes it look easy.
Okay, I believe that's all the questions from Kennedy. If there's no further questions here, we'll conclude the briefing. Thank you very much.
Go ahead, Jeff.
The Nikon's for EVA, and looking in the bag, we expected to find a 50 millimeter and a 35 millimeter. Instead, we found a 50 millimeter and a 28 millimeter lens. And we don't know of any other 35 millimeter lens on board. If you could maybe check into that a little bit and get back with us, see if there's one that we're not finding somewhere.
Roger that, Jeff.
This is Mission Control Houston back aboard Atlantis as we continue to see views from the middeck of the orbiter with Jim Voss, Jeff Williams, and Susan Helms going over all of the EVA tools and equipment that they will be using. Jeff Williams will be serving as EV1 and Jim Voss as EV2 on the spacewalk scheduled to begin tonight. The actual start time of the two gentlemen spacewalk is set for about 9:30 Central Time this evening, although there is the option that if they get ready a little bit sooner, that they can actually start the spacewalk a little bit earlier than that.
Atlantis, Houston, when you get there, we'll take the aero log resets.
Roger, thank you.
Schmidt came to Johnson Space Center about 20 years ago when he began his work in propulsion engineering control. Lonnie, thank you very much for joining us during this busy time.
Well, thanks, John, for having me down here.
Could we start off with asking you to explain just what a propulsion engineer does on the flight control console?
Sure, John. We basically have two responsibilities. One, we're responsible for the hardware, the OMS system, which is the orbital maneuvering system, and the reaction control system. The OMS system is used for the orbital insertion burn and the deorbit burn and any large translations or burns that we have to do on orbit, such as big rendezvous burns. The reaction control system is used to provide the shuttle attitude control while it's on orbit or any small translation burns. Our second responsibility is the propellant budget for the flight. We develop a propellant budget timeline for the flight that includes our red lines for the deorbit and any extension days, and then the propellant that's used for the on-orbit activities, the rendezvous burn, the attitude control of the station stack, and for this mission, the reboost activities that will be taking place in a couple of days.
I see. Tell me a little bit about this mission in particular. When did your work toward preparation for this mission start, and when will your involvement with the mission end?
The mission involvement actually, I would consider, takes place in two phases. One is the pre-mission planning phase, which started approximately 18 months ago when we formed our team manning for the flight. We assigned the lead propulsion engineer and the lead consumables engineer for the flight. They start working with the flight activities officer with the flight plan, working with payload customers on any propulsion requirements for the payload customers, working with the flight dynamics officer on the rendezvous plan and the burn plan for the particular mission. We start developing our propellant budget timelines, also reviewing any crew procedures that will be required during the mission. And then for the actual mission support, started in the pre-launch planning shift, where we come in, we man up the consoles, we get everything initialized. We sent some command loads to the vehicle to initialize the RCS quantity gauging system. The ascent team came in and then took over the ascent phase, and then our first activity during the ascent actually occurs about 10 seconds after the solid rocket boosters are ejected, and we fire the OMS engine for a small OMS assist burn to assist in payload weight to orbit. And then at MECO, when the main engine's cut off, the air reaction control system is then activated and starts providing attitude control and the translation burn to get off the external tank. And then we started performing all of the rendezvous burns and proceeded on, and then our job will be over once we do the deorbit burn. The reaction control system jets are used during entry down to Mach 1, and then post-landing we have some safing activities to perform to get the vehicle safed.
I see. How much more difficult does a rendezvous and docking like that of Atlantis with the International Space Station make your job?
It makes it somewhat a little bit more difficult in that usually the week before the flight there's a lot of activity refining the rendezvous burn plan for the actual trajectory we're going to be flying. But quite honestly, we'd rather fly a rendezvous mission than any other mission because it keeps us busy, it's a lot of fun, and things are constantly changing.
Great. A question has come up about the position of a valve in Atlantis' left OMS engine. Now, we realize that has no impact on the mission, but could you tell us a little bit more about it?
Yes, John. The OMS engine is a very reliable system, and the propellants on board the shuttle are what's called hypergolic. The fuel and oxidizer will ignite on contact. And the valves that are used in the OMS engine are pressure activated. There's a nitrogen bottle on board with a isolation valve, which is activated by the crew on board when they take a switch to the arm press position. That pressurizes a little accumulator, and then the computers will send a command to the engine to open up another valve, which then pressurizes a piston, which is attached to the end of a shaft, and as the shaft moves, there are some gears on the shaft, which has a gear that mates up with the shaft, which is then attached to these valves, which rotate and allow the flow of the propellant to the engines. There's two of these valves in series for each of the propellant, and this particular valve is the valve that controls the downstream side of the oxidizer flow path and the upstream flow path of the fuel system. At the end of the NC2 burn, the valve, or the telemetry indication of the valve indicated that the valve stayed open. The telemetry indication is a transducer that's attached to the end of the shaft. Our thinking is that probably the transducer, for some reason, became disattached from the shaft and that the valve is actually closed. However, we are using the telemetry indication of the fact that the valve is full open to say that yes, the valve could in fact still be open. So it's really no impact to the engine operation other than we won't use it for any of the on-orbit burns. We'll only use it for the de-orbit burn, and with the valve indicating full open, it should be no problem. The other valve will open, the engine will ignite, and everything will be fine.
Generally, Atlantis seems to be performing very, very well. Lonnie, could you evaluate the performance of Atlantis propulsion systems for us?
The performance of the propulsion system right now is quite good. This was the only anomaly that we had been tracking during the flight. The system is operating quite well. And so far, our propellant budget predictions are right on track, and which will make our job a little easier when it comes time to setting or having the propellant available for the reboost.
Speaking of jobs made easier, what are your most challenging or the most satisfying tasks that you encounter on your console?
I think the challenging task is our propellant budgeting activity. We have multiple tanks on board the shuttle which can feed the various systems, so our task is always to manage that propellant in an efficient manner to provide the propellant for all the major mission objectives. At the other hand, we still must also keep track of what we call our red lines, which is the propellant for the deorbit burn, the entry usage, and the weather extension and system extension days, and making sure that we keep the propellant in the right pot, so to speak, so it's available for its correct usage. The satisfaction comes at the end of a mission when you can look back and say everything worked.
How do you feel about playing a part in the development of the International Space Station, and what opportunities do the ISS and space exploration and development in the more distant future offer for people today, especially the young people of today?
Well, first of all, I think I consider myself lucky and honored to be a part of this. I think it's a tremendous honor and privilege to work on the construction of a huge national asset that someday my grandchildren may either fly on it, or at least they can look up in the sky and see it flying over and say, my grandpa worked on that. I have to mention my grandchildren because two of them were born during shuttle flights, STS-51 and STS-79. And as far as the future for the youth of today, there's going to be untold activities on the station with new discoveries being made. Seems like every time we discover something new, that raises new questions on going off and discovering something else down the road. I look back over my career in aerospace and see all the things that have come about in my short time of being here, and one only can wonder and dream about the things that will come out in the future.
It's an exciting time. Lonnie, thank you so much for joining us here. We appreciate you taking these minutes out of a very busy workday, and we're grateful that you shared with us some of your views and some of your knowledge.
Thank you, John, for having us down here. We enjoy it.